Assalamu alaikum, Shabab. Welcome back to the class. I wish you had a good weekend. Before I get started, ya Akhwan, I just want to let you know that remember, we have a quiz this Thursday. It's going to be on the first two sections, Power Screw, Chapter 8. And to give you an idea about what's coming next, there is a good chance, ya Shabab, that we may not. I'm saying there is a good chance that we may not include Chapter 9 one way or another, or maybe one section of it. Chapter 9 is very important. It's related to welding, and you know that welding is very important for our industry. However, ya Shabab, everything is important, and we can't keep teaching you. Our hope is that you are now good enough maybe to even read the chapter and understand it yourself. So that just to let you know, most of the professors, I mean, all of them are actually a little bit late with the material. So this might be, chapter 8 might be the only material left. Of course, the exam is not going to be comprehensive. It will be for the remaining part of chapter 6. I don't think even we will include chapter 7. This is my thinking. Every term we don't include it because, I mean, most of the terms, because chapter 7, you already work on it for the project and you have enough experience with it. And it is in nature, by nature, a very long, it has very long problems. So maybe you will not have that as well. Today, we are going to continue the discussion on the bolts. We'll talk about static failure, factor of safety, and I will do my best during the end of the lecture to give you an extra few minutes, ya Shabab, to fill up the evaluation, my evaluation. And why? Because it is embarrassing. There is only 2 students who submitted the evaluation from your section, which I don't know why. So I will try. I tried with the other section now, around 48% did it. Maybe I will give you another time next class. It is very important for me, ya Shabab. It will teach me how to change things for the future. And just think about it. I have been evaluating you for too long now, so you can spend a few minutes and evaluate me. Today, I had to cancel my office hours. I'm very sorry. I already posted the announcement in the Blackboard. If you need, or if you have any urgent matter, you can always email me and I can definitely arrange for a meeting with you, even at night, okay? If not, then tomorrow I am back, so you can meet with me anytime. I want to comment on the solution, the graded quiz. Probably there are students who got the wrong solution. And يعني, I am very sorry if I, by mistake, posted your quiz for somebody else. Once or twice, I don't know. It is very hectic. You deserve to get the graded quiz back, but at the same time, it's very difficult. It's very difficult. So I think one student sent me an email, told me, I got a full mark. The solution, which was marked for me, got 0, and it's not even my solution. So if you got this problem, please let me know. I will fix it. And I will try to improve it, you know. I think that's it. That's what I want to talk about. So let's go back to the lecture. What we talked about last time was the analysis of the threaded joint, I mean, bolted joint. And we talked that there is the load applied on a joint will be partially distributed among the bolt and the member. And the governing factor is C, which is gonna share the load between the member and the bolt itself. Okay, C was estimated as KB, calculated as KB over KB plus KM, and we said that the bolt will take C multiplied by P, and thus the member will take 1 minus C multiplied by P. This is what we said. Most importantly is this relation, which shows the bolt, the resultant load on the bolt, which is the load coming from CP, as well as Fi, which we are going to talk today in a lot about Fi. And then we said that this is valid for Fm less than 0, which means compression, there is a clamber. Then we talked about Fm, which is the force on the member, and because the tension in the bolt is causing compression on the member, that's why Fi is negative here, while the tension from the load is still trying to separate the member, and that's why it is positive. This again is valid for Fm is less than 0. Here there is an example of the bolt grip and KB, KM, C, and what is 1 over C, just to show you how is this ratio playing out. Now, what is important here is this. We said that the force on the bolt is equal to CP plus Fi. Now, while C is the stiffness constant, we can calculate it, and P is the external load, we did not talk about Fi. What is this Fi? And we told you that Fi is actually the preload, and the preload is the one that we apply before the machine even run. So it is determined by us. And let me tell you an interesting story over here. The preload, ya shabab, is basically applied for a threaded bolt by torque. Very simple. You have a nut, then what do? You bring the socket, okay? And the socket is connected to an arm. You apply the load F, you multiply it by this distance, and what do you get? You get a moment. This moment is applied like a torque. And this torque is what is going to clamp the bolt. How? The bolt, as you clamp it, the nut wants to advance, but because the member is strong, then the nut cannot move on. So what happens? The bolt gets moved on. And that's how the bolt gets stretched. And let me tell you, how important is this torque? Because the amount of torque that you will apply will determine how much the bolt will stretch. And if you know how much the bolt stretched, you will, through the relation, if you know delta equals to FL over AE, you will know from the stretchness of the bolt how much is the F, which is the generated Fi, which is the pretension or the preload. Now, let me tell you an interesting story. It will take some time from the lecture, but it is going to teach you a lot about what to expect when you go to the industry. Okay? So, long ago, I remember maybe when I was in high school, okay? One day we woke up, okay? We go to change the tires of cars, and then we saw something very strange. The machinist there or the technician who changed the tire, instead of using this conventional wrench, okay, they started to use guns, the hydraulic guns, okay? So it's very interesting. You look at it, wow, it just makes that sound and it rotates. But after some period of time, everybody in the kingdom start to teach their kids, start to tell their friend, when you go to change their tire, tell the guy, the machinist, or I mean the technician, not to use the gun. And it was very funny. It's like, oh, we are against technology. And the story goes like this. In our nature as a culture here, the more the better. صح ولا لا يا شباب؟ the more the better. كل شيء لازم بالطق، كل شيء لازم أقوى يعني أحسن. You understand? So what happened? This gun has a dial. الجماعة اللي يستخدموه جاوا قالوا الحين أنا when I turn on this gun and start twisting the snot, what if it is applying little torque and this poor guy go drive his car in the highway and then all of a sudden he see the tire just running away and the car will just flip and then the guy might die. So وش قالوا ادعس على الأخير وتعال وحط على أقوى تورك وهات. And then what happened? People didn't know anything. But after 1 year, they realized إنه ما في حد في الأرض ممكن يفتح التاير again. Believe me, it was a disaster. It's like يمكن, maybe, I don't know if there is a statistics, but there is nobody I know who hadn't had a problem with at least one bolt. And if you cannot open it, it's a big deal. You need to torch it. And I mean, when they try to open it up, the nut, which is hexagonal, turned round, it's worn out, and they couldn't open it up. They couldn't. And that's why everybody said, don't use it, don't use it. Who's wrong? Not us, who got freaked out from this technology. لأن like 20 years ago, يا شباب, 25 years ago, people use manual, branches to clamp. So who's wrong? The technician. Then today they realize in الموضوع مو جنون. There is a torque. You put the torque, the car has a recommendation, maybe the torque is 45 Newton meter. You put it على 45, you screw it, and that's it. No more, no less. Nowadays, nobody is using manual. They learned their lesson. However, your car is important. You are, as an individual, is important. But if your car got stuck with one nut, you can rent one. I mean, it's not the end of the world. But if you get a turbine, which is supplying power to the entire city, and you got stuck with one nut, turbine might have 100 nuts, and then you get stuck with one. By the way, what I am telling you is not a joke. It's stories, I get them from engineers in the industry. I'm not going to mention the name of the company, but there was one company who spent 1 full month trying to unscrew one nut for a big turbine. And nut, ya shabab, is way bigger than this book. Way bigger than this book. So what the technician do? They put the wrench and then they put a long pipe inside it and they start to push, they couldn't. They torch it with torch to expand it, they couldn't. After struggle, I mean, this turbine cost 35 millions, 40 millions, not your car, 100,000. And if it slowed down the production of oil or gas, it cost the country a lot. And if it causes an outage of power supply to a city, it's a big deal. So I am not going to get into the detail, but one company realized through some investigation that senior technicians كانوا مغرورين. مغرور. Senior technician, he lived 30 years. He knows turbines, this massive multi-million dollars machine. He knows it very, very well, piece by piece. فالرجال شوية شاف حال على الناس قال أنا ما أستخدم torque wrench. To do what is the torque wrench? The torque wrench is a wrench which has a hexagonal socket, and on top there is a dial with a gauge like this. So when you wrench, the dial, this dial moves. So logically, while this gentleman, the senior technician, is trying to torque the knot, somebody should look down and say, okay, a little more. When you reach 100, please stop. لكن الرجال قال أنا راعيها. أنا ما أحتاج تورك رنش. أنا إيدي تحس في التورك. خبرة. فجاء وقام يدعس على النات. يدعس طبعا اكتشفوا الشركة إن الرجال ما يستخدم التورك رنش، هذا الخبير، وللأسف يطلع التوربين من إيده ويروح الاندستري بعد 15 سنة 10 سنوات 5 سنوات يرجع التوربين for some maintenance ويبلشون فيه. Very interesting story, very simple, foolish, but this tiny little mistake caused a lot. لما تيجي لشركة الساعات حقتهم غالية، تجي وتقول لهم 1 month تشتغل على نات واحدة، وش يسوون؟ جنون. هذه شركة ربحية. يقول لك النات هذه ما تفتحها في 10 دقائق، تفتحها في شهر. مجنون. يمكن الخسائر توصل بمئات الألوف. It's so funny, but this is true. So, إذن يا شباب, after all of this long story, you should know that this torque is tricky. And since we use bolts everywhere, most of us probably overload it. And so there are two ways. إما إن إحنا نجي على البولت, while we are screwing the bolt, we measure how long the bolt gets stretched out, and we try to estimate this delta, a good delta. طبعا هذا ضرب من الجنون، صح؟ It's very while you are clamping things, the bolt is inside. How can you read? And not only this, the displacement is measured in micron. You need to put very sensitive devices, not a ruler. So most of the time, people use torque wrench. They don't use displacement to say, okay, you reach 600 micron, stop. No, use torque. Very, very convenient. The torque wrench, by the way, يا شباب, ما توجع اليد ولا تعض ولا تأذي، بس هو الغرور. يعني الإنسان لما يقتر بنفسه يقول الكونفيدنس، اوفر كونفيدنس، إنه أنا ما أحتاج تورك رينج. This is the problem. عشان كذا في الاندستري يا شباب يجلدوهم. ما ينفع. You can't just say أنا خبرة وأعرف، ولا يجي ويقول خليني ألمس هذا 30 درجة مئوية. Doesn't work this way يا شباب. So what happens now? It is very important to know this time. By the way, I'm gonna tell you one little thing. When you go to the industry, when you graduate, شباب, the technician may not like you. They don't like you. You have to be, يعني most of the time, you have to be ready to be hated. It's okay. Because they think that you are too young to become more senior as an engineer with regard to a technician who spent 30 years of career of experience. But unfortunately, without degrading people, بدون ما ان احنا نقلل من قدر حد, this is the knowledge. النولج هي اللي الآن خلت الموجودين الآن هنا في الاجتماع هذه المحاضرة كلهم, if they are listening to me, of course, not playing something, they are very much convinced that torque now is the way. Because you are engineer, you understand بأنه ما هي فوضى. And you can easily make mistake. But unfortunately, technicians, because they are not they are not educated as you. If they are educated as you, they will become engineers. They make the mistake. And this is when you appreciate why you are here today. It's very important. Okay? So if you remember, we can use our knowledge by using the torque equation and assuming that there is maybe a washer, which is going to be like a collar here. We can add them together, but we need to tweak this a little bit. So what are we going to do? I want you to remember the equation tan lambda. Look, tan lambda, lambda is the lead angle, is equal to L, the lead, divided by dm. dm is the mean diameter. We talked about the mean diameter with power screw, but we didn't talk about the mean diameter with the threaded fasteners. So the mean diameter for a threaded fastener is going to be what? If you go to the table A1, A1, A2, you will find AT, the tensile stress area, and also you will find AR. AR is the root diameter, the diameter at the root. So you can say that this is equal to pi over 4 dr square. And when you find dr, you can find dm as the nominal diameter of the bolt, which we give you, plus dr over 2. That's how you calculate dm. Now, so you know dm by, and L is the lead. We talked about the lead, is how much the bolt will advance per rotation. And we will have example about this. Don't worry about it. So we took the torque equation, we substitute the lead as tan lambda. Secant alpha, we told you that in general, alpha is 30 degrees. So we will keep it that way. And with some approximation, you know, assuming that the collar, which is like the washer, is equal to 1.5 the diameter of the bolt, then dividing it by 2 as an approximation, then we will end up with this torque equation. This torque equation, ya shabab, has a force. That force over there is Fi. So basically, we are relating how much is Fi, which is the preload, if I apply this much of torque. Do you understand? Now, this is too much for engineers. Too much. They don't like to calculate this. ترى يا شباب لما تطلعون engineer في أرامكو كده senior engineer, okay? Spend 20 years in the industry. أكثر شيء ممكن يحسبه هو F over A. And it is not because he's not engineer, he doesn't like mathematics. No, it's because they always need fast answers. So what do? We can take this part, which is a common factor, as K, which is called the torque coefficient. And then we can now write the equation for our engineer as T equals to K multiplied by Fi multiplied by D. Now look, D يا شباب is the nominal diameter of the bolt. صح؟ تذكرون في example we said 3 over 4, 1 over 2, UNF, whatever. So it's very well known. You know the diameter of the bolt that you are screwing. It's not a big deal. Then Fi is the preload, which I'm going to tell you what is it. There is a standard value. لأنه هنا يا شباب المعادلة, the unknown is the torque. The Fi, which is the preload, is actually very, very simple to calculate. And that's why we're not going to talk about it right now. Our job is to teach you here how to find this magical torque. So magical torque means your joint will be good, not overloaded, not underloaded. And when you bring it back after 10 years, we can easily unscrew the nut without leaking. Okay? It's actually a magical number. So then we have the K factor. Now the K factor is this big guy, but there is a table which is provided here for common bolt conditions. For example, zinc bladed is a very common one, non-bladed finish. This is lubricated. So in general, ya shabab, if you know that your bolted joint is lubricated, you can use K as 0.18. What is the preload? I'm going to show it to you. It's very simple. What is the diameter of the bolt is also very well known. There you go. You got the torque. You got this magical torque. Do you understand? So, so what are we going to do? We are going to discuss together a simple example. We're not going to solve it. I have way more important example to solve with you together with this limited time that we have in terms of lectures, okay? All right. Now, if you recall, the name of the bolt, this is 3/4. This is the diameter D. Same diameter we talked about in the torque equation. Then we have 16 UNF. This is fine threading. This one is capital N. Capital N, ya shabab, is the number of thread per inch, which, by the way, can let you calculate L, because L is 1/N. L is 1/N. Okay? And then we have 2.5, which is the length of the bolt. We know this. And then SAE grade 5. SAE grade 5 will let you determine what is the proof strength. You remember the proof strength? The strength which is here, this is yield, and this is ultimate. Do you understand? Now, what it says here, that the load in the bolt is 6 kilo-pound, the load on the bolt. And the pre-tension is 25. I want you to understand one thing. This feel. انتم ممكن يا شباب تفكرون كيف ان the load is only 6 while the preload is 25. This is a huge, really huge. Okay? And I'm going to comment on this again. So the joint stiffness KB and KM are given to you. Now, this is a very generous question. The reason why KB and KM were given to you is because we don't want you to be busy with them. We want to see if you know how to calculate other things. What are these other things? Of course, we want to know the preload and surface load stresses. What are the stresses generated in the bolt? We want to know the torque using the two equations. The simplified one, which is KFID, and the other one with the big parentheses. Okay? So let me show you how are we going to do this. So in here, ya akhwan, if you look, I'm zooming this out for you. We go to table 8.2. Okay? So table 8.2, if we go there, we will find AT. How? We know that the bolt is 3/4 in diameter, and we know it is 16 UNF. We will find our bolt, and from that bolt, we will be able to find the tensile stress area. Okay? Now, when we find the tensile stress area, if you tell me what is the stress generated in the bolt, if you apply the preload, so the preload is Fi. For bolt, ya shabab, whenever we talk about bolt, any stress is going to be calculated with respect to AT. هذا اللي احنا سميناها tensile stress area. And I talked to you about it, so I'm not going to repeat it again. So if I do this, I will find the sigma I. Sigma I is the preload stress. And then a preload as a force, if you divide it by 80, it becomes stress. So this is it. How much is it? 67 kpsi. Okay? Then we know KB, KB, and KM, so we can find C. Then the question says, what is the stress in the bolt? Now, if you remember, the force in the bolt is equal to CP plus Fi. So if I want to know the stress in the bolt, all what I need to do is to divide by 80 and 80 over here. You see that? So this is C, which I calculated. P is given to me, it was 6. And Fi, I know it, it was 25. AT, I found it from the table. So I am done. Now, what I want to tell you is something here. When we have this part, which is Fi over At, we calculated the stress because of the preload. And then Cp over At will calculate the load, the stress because of the applied load. Can you believe, ya shabab, that you have 67 before even you switch on the engine? 67. And then when you apply the load, you get 72. Just 5 kbsi extra. And when you look at the table for SAE grade 5, you will find that SP is actually 85. This is not far away from this. Not far away from it. You understand? Now, you may ask me a question. تقول طيب ليش احنا خانقين نفسنا كذا؟ ليش ما نخلي البريلود أقل؟ ها؟ Unfortunately, these values of a preload, you will see that they are recommended, because if you make the preload smaller, you will probably get leak. Do you understand? So there is no escape. And you will have always tiny gap between the proof strength and the load that you are applying. And for that reason, the only way, إذا كان عندك load 1000 Newton, is to put too many bolts. When you divide it over the bolt, each bolt will take a little tiny load. Do you understand? And this tiny load will push the stress a little bit, like 5 kbsi or something, so you are still away from the proof strength. You understand? Now, let's go to the torque equation. In the question, okay, it wasn't written that the bolt is zinc plated. I think it's a mistake. But if you want to use this torque relation, K here is 0.2. 0.2, if you go back to the table, you will see that 0.2 is for zinc-plated joint. In the homework, you should know this. It will be given to you. You will be told about the condition. Do you understand? So otherwise, in here, we are using zinc-plated. So this is 0.2. Fi, we know it. It's a 25 kilopound. And then we have the diameter, which is a 3 over 4 point. 3 over 4 is 0.75. So we calculated the torque. Okay? Now, the question is asking about using the other equation. So the other equation is this one, the big one. So one thing that you need to do to find the other equation is to find the tan lambda. So tan lambda, ya shabab, in order to find lambda, okay, lambda, we said that tan lambda is equals to L over by dm. And we said that dm is equal to dr plus d over 2. This is what it does. Here, dr is calculated from the root area in the table. So we found dr, and then we calculated dm. This isn't the difficult part. From my experience teaching this course for nearly 7-8 years, most of the students get confused here because of one thing. They look at the equation, they say lambda is the tan inverse of the lead divided by dm. We know dm. They get confused why the lead is 1. Why it became 1, but it's actually not 1. It's 1 over n. Do you see that? That's the lead. So when you do that, you get the angle, and knowing that secant alpha is secant 30, as we told you before, everything else is known, and you will be able to find the torque, which is how much? 5% different than this torque. Not very much different, okay? So this is just to show you that the two equations are equivalent, okay? All right. Now, in order to finish up, so we have time, now let's talk about static loading. If you remember, ya shabab, when we talked about static loading, we talked about a factor of safety NY, and we said that all what you need to do is to take the yield strength and divide it by the applied load. صح؟ So دائما عشان نطلع الفاكتور of safety we take the property or the strength and we divide it by the amount of load that we're applying. In here logically يا شباب إذا كان البروف strength حق البولت is the cap, the marker for failure, then I can assume that NP is going to be equals to a SP, which is the yield, kind of. It is the proof strength divided by what? By sigma bolt. Now, what is sigma bolt? We calculated it. It is sigma bolt is equals to CP plus FI divided by 80. So if you substitute this in here and you divide it, you divide SB by that number, you will get the first factor of safety guarding against the proof strength. This is like yield, NP. Okay, but the problem is this. Because the proof strength is not far away from the load, usually NP is not too high. It's not too high. It's 1.1, 1.2, something very small. So people doesn't feel comfortable. Are we going to be safe or not? For that reason, they apply different factor, which is called the load factor. The load factor is NL, which is equal to SP AT minus FI divided by CP. This is another factor of safety, which is called what? Load factor. The load factor is guarding against overloading. And you don't overload it. So in here, the difference is this. NP is looking always for the SP. يقارن بالSP. هذا يقارن بالload. كأنه عنده you have a load which is critical and you don't want to reach that load. Do you understand? So this is NL, the load factor, very well known. The last one is this. The load factor, ya shabab, will guard you against overloading. The proof factor, NP, will guard you against, proof strength. But as I keep telling you in the course, doesn't necessarily mean, ya shabab, that things are breaking apart. They don't need to break apart in order to fail. Failure can happen, for example, in the joint because of leaking. Leaking is the member is not clamped very well. So by saying that the force in the member is equal to 1 minus C multiplied by B minus Fi, remember we said Fm should be less than 0. So what are we going to do? If we put intentionally Fm as 0, then this load P is going to be a special load. It is going to be the load that causes Fm to become 0. So this P0 become like a strength. This strength is called, we put it here, and then we divide it by the load that we are applying. And what happened? We get a factor of safety. This factor of safety, we call it N0. N0 is equal to Fi divided by P multiplied by 1 minus C. What is this F0? N0. هذا اللي يا شباب guarding against joint separation. It is not a fracture. The bolt is safe. The member is safe, but it is loose. It is loose. Fm is 0. So in summary, we have 3 factors of safety. The first one is NP, guarding against yielding due to the, approaching the proof strength. The second one is NL, due to overloading. And the third one is N0, due to separation of the member. Most of the time, whenever we have a bolted joint, we ask you to find these three factors of safety. Okay? Now, the last slide that we're going to talk about is, okay, what is this FI? In the factory, في مصنع تويوتا، في مصنع GE، كم يحطوا ال FI? How much? Well, it turns out that FI is a function of FP. What is FP? If you talk about stress, S, it is equal to the load F over area. So if I put S as SP, then the force is FP. صح ولا لا? It's the load that causes SP. So it is FP. And the area is always the tensile stress area. So indeed, FP is equal to SP multiplied by AT. لاحظوا يا شباب, both values, SP and AT, are tabulated. So if I know the bolt, I can go to the table and find SP and find AT. Multiply them together and I get FP. طيب, when I get FB, how can I find FI? Well, you have two conditions. Condition الأول, non-permanent connection. يعني كيف؟ يعني لما أنت تجي وتركب الماكينة حقت السيارة، هل أنت تتوقع أن العميل يمكن يوم من الأيام يفتح الماكينة ولا لا؟ Of course. العميل حر، شرى السيارة وقال أنا أبي أفتح الماكينة وأغيرها ولا أنظفها. So what do? You multiply FP by 0.75. 75%. If it is non-permanent, يعني شلون؟ أبغى أرجعها بعد 10 سنين وأفتحها يا أخي. Do you understand? So, but what if you want to build a bridge? يا شباب, البريدج ما ينفع تبنيه civil engineering ها وتقول والله غيرنا راينا بنفكها الأسبوع إجازة والأسبوع اللي بعده نركبه. No, this doesn't happen. When you build a bridge, it's forever. Unless there is, لا قدر الله, يعني God forbid, a hurricane or something, it will collapse. So how much do you push it? Can you believe it? 90% of the proof load. 90%. 90. خلاص ما بقى شيء على البروف لود. عشان كذا for permanent joint you will probably need hundreds bolts for per joint, because the remaining 10% of the load has to be, you know, you have to put two tiny little load in each bolt عشان انت ما توصل البروف strength. So this is the equation which I discussed with you. In the question, you will always be told this is a permanent joint or non-permanent joint. Do you understand? Now, the question is this. What if you were not told if the joint is permanent or non-permanent? Which way to go?
Take the average.
حلوة هذه. الافرج يحل كل شيء. ها يا شباب.
انه باي ذا لوجيك انا على ايش قاعد احل بالضبط.
مثلا ممكن تكون المسألة واضحة.
شيء المفروض
شيء ينفتح شيء ينفتح. لكن يا شباب in general يعني بشكل عام احنا نتكلم عن mechanical engineer ما نتكلم عن civil engineer. In general we build things knowingly that we may need to unlock them. So if nothing was given to you, nothing, and you get confused, make it non-permanent. A logical thing in a bolted joint are non-permanent. That's the logical thing. This is the logic. It has. احنا ما قلنا ان هي bolted ولا كان عملنا لها welding. Do you understand? But the comparison is not like this. There are applications where bolted joint will be permanent. However, we will assume that it is not permanent if it is not given to us, unless otherwise stated. So, one last point. لو جيت انت واخذت ستيل ورحت الماشين شوب وقلت لهم ابغاكم تعملوا لي هذا الستيل bolted joint. bolt joint. I want it to be screw. رحت على التيبل ما شفت البروف سترينث، ما حصلت هذا الستيل انت جايبه من ورشه ولا كذا ما تعرف. So what do you do? How do you know the proof strength of it? Very simple. The proof strength is nearly 85% of the yield strength. So شوف يا شباب ما تستخدم هذا في الإكزام. If you did not find the proof strength from the tables, you can assume that the proof strength is 85% of the yield. Okay? That's it يا شباب. إن شاء الله next class we'll solve an example. What I said in the beginning يا أخوان, I am gonna now take your attendance, and while I'm taking your attendance, if I call your name, I would kindly ask you to go to the blackboard, I think, where you will find the course evaluation and try to fill it up for me, okay? Thank you. Where are you يا شباب? I need to see you. Hussein?
Yes.
Saleh?
Yes.
Saeed?
Yes.
Adnan?
Yes.
محمد المدن؟ المدن؟ صالح السلطان؟
Yes, Doctor.
علي طويليب؟
Yes.
العمري وليد؟
يس
فيصل العطوي؟
موجود دكتور.
علي؟
Yes, Doctor.
محمد؟
Yes, Doctor.
مفلح؟
Yes, Doctor.
فهد؟
موجود.
فيصل؟
Yes, Doctor.
مصلح؟
Yes, Doctor.
سلمان؟
موجود دكتور.
فارس؟
Yes, Doctor.
خالد؟
Yes, Doctor.
سعد؟
Yes, Doctor.
عمر؟
Yes, I'm here.
ثامر؟
Yes.
مصطفى؟
Yes, Doctor.
فواز العوفي؟
Yes, Doctor.
ماجد؟ No,
Yes.
أمجد.
Yes.
أمجد sorry. فيصل؟
Yes, Doctor.
محمد؟
Yes, Doctor.
ناصر؟
Yes, Doctor.
عبد الرحمن؟
Yes, Doctor.
عمر؟
Yes.
بديوي؟
Yes.
محمد؟ مؤيد؟
Yes, Doctor.
محمد.
Yes, Doctor.
Okay, thank you so much يا شباب. Please fill up the evaluation and then you can leave. Thank you.